So again, if I say something weird, you should let me know. Double integrals in polar coordinates is going to get chilly because we'll do double integrals in polar coordinates. That's a good joke. Polar coordinates. Let's review them first. Here's the typical formula. We learned it from Calculus 2. Polar coordinates are defined as xr cosine theta and xr sine theta. All these formulas are coming from the right triangle. Additional to that, we had formulas. So this formula, two formulas, help us to jump from x to r and theta, from Cartesian or rectangular to polar. And then from here, we also have two formulas, x squared plus y squared equals r squared. And then we had a formula for the angle tangent of theta equals y over x, rise over run. That's a review from Calculus 2. If you don't remember, it's fine. Now you remember. I literally just gave it away. And the definition was, see, you can define it in any language, but it's literally the same thing. The pole, the point, the distance between the pole and the point is r. The angle with the positive x is usually theta, and in Europe we like to use phi. This is phi. You see how beautiful it is? Phi or phi. In English, it looks like that. If you want to jump from x to y, it becomes r comma theta. Pole, it's called literally pole, 0, 0. And then the distance between the point, we can call it p if you want, is r, angle is theta. And then the vertical distance is y, and that's why x and y and r create right triangle, and the formula comes from there. X squared plus y squared equals r squared. So we also learn in Calculus 2 areas and through sectors. You might not remember that, but it's fine. Here it is. We learn, it will be important in this class, we learn that instead of approximating all of this with rectangles, which will be super weird, like why would you do that? We decide to approximate them with sectors. Sector is this piece of pie or pizza. And sector has a formula. The area of the sector has a formula. So this is what we did. We're approximating with different sectors. Some of them can give up, can give down, doesn't matter. Overestimation, underestimation. But the area of a sector, this one in blue, is known through the formula r squared over 2 and the angle delta theta. You don't have to write this down. This is just a review because we will have that again. So now the most important for this chapter is the double integral in polar is not the same as double integral we learned before. Did you like double integrals? First with respect to x, then with respect to y. Did you like it? No? Okay. I really like it. I feel it's so fun. Your brain has to just suggest that first, so again, x first is a variable, everything else is a constant. Okay, integrating. So if y is a constant, it's not y squared over 2 anymore. It's going to be yx, like, wow. And the brain doesn't like it. But then you have to integrate again, changing the variable. When in front of you, there's like 3 letters. So anyway, the upper level math you go, the higher you go, the less numbers they're going to be. The more letters show up. So that's why many people say, I lost myself in math when there was no numbers anymore. Here's the definition of the polar coordinate formula for double integral. So D should be below. Sometimes people type it like this, but it's not actually a nice idea. Double integral over D, and D is below below both of them. It's not here or here. Means it's some kind of neighborhood or region D. Of f, x, y, dx, dy, how do we convert into polar? Double integral of the same D. Now f depends on r and theta. That's the whole point. And there's a special extra term. You multiply it by r. dr, there's a typo here. dr, d theta. dr, d theta. That's a formula. So before we did not have any special term. Now we do. We multiply by r. It comes from derivation. When you derive how to jump from Cartesian to polar, r pops out. And you'll have to remember it. And most students don't remember the R. So you see, do not forget the R. So I really like that my friend made this funny joke, and it totally helped. At first I was teaching this. Many students failed this problem on the exam because they would forget the R. But this joke show up, nobody failed it anymore. It's amazing. It actually works. Remember, you're like a pirate. This is how you read the double integral. Double integral f of r theta, r d theta. Then it became so funny, everyone remembered it. Like, it's hilarious, but it's good. And there's a whole psychological study that the sense of humor helps you to remember stupid formulas. Like, how would you remember a long formula from some kind of arc length? If you have a funny joke about it, you remember. So, did I tell you about the cosine being racist joke? Right? So somehow, like, it works. If it works for students, cosine, double and half angle formula is 1 plus cosine, because cosine likes cosine, whatever. So if it works for you, then I'm fine with that. So r d theta. So polar, you're like a pirate. Remember that. Let's practice. Just write down the problem. Calculate the following integral. D is a disk. X squared plus y squared less or equal than 4. Here it is. And then we want to find double integral over the D, which is a disk. X squared plus y squared to the 3/2 dx dy. All those notes are posted in the modules. I keep reminding you, I'm posting all the notes in the modules. So, disk is not a circle, for you to know. D, this is a circle. So why did they call it disk then? Because of this inequality. Inequality means what? Shaded. So if you shade it, now it's a disk. So it's actually an object. It's not a circle. It's like a literal object, a disk. So less or equal means the border. That's equal for. And then less means also inside. That's what D is. That's D. Rule of thumb, if you see x squared plus y squared, some kind of disks, we use polar coordinates. If you don't see that, usually those are Cartesian. And we're going to do also, after the exam, spherical and cylindrical coordinates. They have different ideas. But for now, this is good enough. Triple integrals are coming, basically, after the exam. So f of x comma y. Write f in polar coordinates. Step 1. Write f in polar first. What is f? I don't know. I don't see f. Where is f? So let me go back to the formula. This is f. Here it is. F of x of y dx dy. Where is f in this particular problem? X squared plus y squared to the 3/2. Whatever is inside, that's f. So let me write down for you. Double integral over d f x comma y dx dy. That's how I know what f is. So let's write down f is x squared plus y squared raised to the 3/2. Step 1, rewrite it in polar. We're changing everything to polar. So you use the knowledge you know. And you don't have lots of formulas. This is what you have. So you stare at this and you rewrite. So you can write down x as r cosine, y is r sine. But there's a shortcut. X squared plus y squared equals r squared. So we're using formula. X squared plus y squared equals r squared. R squared. But don't forget it's raised to the 3/2. Does it make sense? So first rewrite. Yes.
What was the other one under the x squared?
Let me check. Here. Oh, tangent. Let me keep it here. Tangent theta equals y over x. Yes, if you have tangent sines and cosines, you use that formula to jump between. But the first two formulas, this formula helps you to jump to polar. The second formula helps you to jump to Cartesian, and so on. So you need to be just smart about that. But we only have 3 formulas, so it's kind of not very challenging to choose one of those. The system, that's formula number 1, this famous 2, and the angle. Only 3 formulas. So now we have r squared to the 3/2, which is what? Just r cube. R cube. So now we know f is actually r cube. And that's why polar coordinates are used. You probably will be asking a lot why I'm doing all of this. Outside of just torturing students for the diploma, you just see x squared plus y squared to the power. That is hard. Like working with squares, radicals, sums is hard. It ended up to be r cubed. How convenient is that? One variable and it's cubed. No fractions, nothing. So actually polar coordinates work well when it comes to x squared plus y squares, disks, spheres, all that kind of things. So, thus, therefore, then, whatever, f, now it can be written of r comma theta, distance from the pole to the point, comma angle with the positive x, equals just r cubed. You can put it in the box, so this is kind of a nice summary. Oh, so we converted it from x and y to r and theta. Step 2. Step 2. Let me put it in blue. So let's see what I already finished. I need to go from this formula, which we have right now, just a function, to this. I did step 1. I found f. R is part of the formula. What's left is to find borders, A, B, C, D, which is where you're practicing doing in your homework. Did you finish your homework? Oh, who started it like half an hour before deadline? Seriously? I looked like, oh, okay. Sure. The good luck was that. When I saw some people start hours before that, the good luck was that. There was too much stuff over there. So, step 2. Find limits of integrations. They don't have to be called A, B, C, D, right? So just let's do limits. Limits of integrations. Limits of integration. And there are many limits. We don't just have one integral. We have 2, so we have 4 limits. Some of them sometimes are numbers. Some of them sometimes are functions, as you saw from the homework. Minus square root to square root, and blah, blah, blah. So that depends. The more we work on this, the more you will understand when is which is happening. So that's coming from the given D. D. Whatever D is, that tells you the limits of integration. D is a disk. Let me sketch the graph. This is how the disk looks like. This disk is not just a general disk, it's a specific one. X squared plus y squared less or equal than 2 squared. That's how I can write it down, 4. So it's centered at 0 and have radius 2, like that. Is that correct? Is this a disk on the picture? No. Because I need to shade it. That's a circle. The disk comes with this inequality. Less means I need to shade everything inside. That is the disk. And that's why it's not called a circle. It's a disk. Disk radius 2 and everything is shaded. So let me skip some space and I will start building the integral. I think this way it's easier to understand. Step 3, integral. Build the integral. We have a formula, integral over D. F of x was given as x squared plus y squared to the 3/2 dx dy equals, formula says double integral, formula says f, right? So that was f, but now r and theta should go inside, no x and no y. And we did successfully convert our f into r cubed. R cubed. Formula says this is polar, so it's r dr d theta. So let me write it down. R dr d theta. Don't forget that. You will be asking yourself, where did this r come from? I don't remember she ever mentioned that. It comes from the derivation. You can check the theorem how they derived this formula. So remember, r is there as part of the formula. Yes.
Will all the numbers in D be the same?
Oh, let's find out. You mean the limits of integration?
Yeah.
Yeah, let's find out right now. So I skipped some space to actually put it in front of you. What are we doing in which step? Yeah, thank you for asking. Let's see. So we have a circle. First of all, so I put a bar here and I start thinking. So what is my r doing? Question mark, is r 2? Because x squared plus y squared equals 2 squared. So you just told me radius is 2. So that's it. Radius is constant. Yes or no? No. I can see people saying. So what is radius doing? No, radius is not 2. There's an inequality happening. Since this is r squared, x squared plus y squared is r squared. It's less than equal than 2 squared. So what does it mean? R is keep changing from what to what? So minus 2 and 2? Definitely I agree with 2. The biggest one is 2. That's how we get 2 squared. 0. Let's see why. This is radius, r. It can be 2, 1/2, let me zoom in. 1/2, 0.3, 0. This is the same, this is the same, same. Those are all r's. R is limited from nothing. So the smallest part of the disk, the center, r equals 0, to the biggest part of the disk, which is circumference, and circumference happens at 2. Now I can put it there. You see, I'm gonna color code it nicely. Let me use purple color. Whatever happens, so you have to be consistent, especially if you don't work with numbers everywhere. dr is the inside integral. So sometimes people explain it like this. Thus, 0 and 2 will go to the inside integral. 0 and 2. So you see, double integral is not just something in order, which is true, it is in order. But whatever is integral inside goes first. The next one is a middle, the next one, and then finally the last one is outside. So the order is from inside to outside, like an onion. In core of the onion, next layer, and you peel it. So you always start with the core. So you have to be consistent. You cannot put stuff randomly, unless they're all constants, then you can. So what my point is, dr comes first. That's why 0 and 2 comes first, inside. Does it make sense? Should be consistent, basically. Now the outside is theta. This is how, when you become a scientist, you work with this a lot. And you will have many dr, d theta, d phi, all in them in the row. We're gonna have it after the exam too. And this is how you see it. You look, let me color code it. You look at this guy and you're like, oh, it's d theta. Oh, d theta is the angle. Good point. I need to figure out what theta is. And put it over here, right? So let's figure out what theta is. Theta is the angle of rotation. We're starting from 0, which is with the positive back to definition. Here's theta. That's the angle with the positive x. And then theta becomes bigger. Ends up at 2 pi. Oh, really, it can go more and more. And that's how spirals are created, blah, blah, blah. But in this case, we have a circle. What is my theta doing? Guess. From 0, I agree, 0 and 2 pi. If we only had half of the disk, then it'll be from minus pi to pi or whatever. We can just shrink it. If it will be quarter like that, we will adjust accordingly. So in this case, it's simple. It's just from 0 to 2 pi. So we jump from x and y into r and theta. R is from 0 to 2, theta from 0 to 2 pi, and the relationship is r squared is less than equal than 2 squared, because x squared plus y squared equals r squared. Then we put it in black. This is how we convert it from x to y. Let me put it in the box. To polar. Whatever is in this box is we learn it in Calculus 2 class at the very end. That's why you don't remember it. At the very end, everyone prepares for finals, so nobody remembers this. That's why I never bother to be too tedious in Calculus 2, because we relearn it again right now. And that's what I mentioned in my class last semester. It's the same thing, so it's nothing scary. I'm putting it here in green, 0 to pi. The conversion is completed. And then we're gonna actually integrate. The conversion is completed. Let's see again. Integral from 0 to pi. Integral from 0 to 2. R cubed was our function. They just gave it to us. Don't be bothered. They usually give you that. So your job is just to carefully convert it. R, where did this R come from? Part of the formula. Maybe let me write down once. That's formula. R dr d theta. So write down R dr d theta. It's a tail of the polar double integral. But then limits are challenging. You actually have to draw the picture. Usually picture helps you and so on. Find limits of integration. Usually picture helps. Picture or even just a sketch helps you to visualize what is happening. This is the hardest part. Integrating usually is not hard. Can you do that? If I list 5 integrals from the exam in the multiple choice, can you choose the correct one? And unfortunately, the correct one will not be R cubed times R. The correct one will be a simplified one. I already saw the coordinator did that. From 0 to 2 pi. From 0 to 2, R to the 4 dr d theta. So can you choose this one? Like, why is it R to the 4? Because it was function R cubed and the formula gives you R. Good? Now you integrate. That's what you did in your homework. Well, you need to be good in integrating double integrals. Triple doesn't really matter, but double. Jumping from one integral to double integral is extremely important to teach you that. You're not supposed to pass this class without knowing double integrals. That's one of the core technical skills you have to have. Converting things is challenging. You might understand it, maybe understand it a bit later in different classes and stuff, but at least calculating double integrals is important. Very interesting. I don't know if did you like the professor last time? I like the person. He's a very nice person. But I never saw him teaching, so I don't know the teaching skills. But he's very kind, so I like him a lot. So what I was trying to say is, I'm not sure if he mentioned that if double integral have all numbers, you can switch the order of integration. Only when, did he mention that? Only when double integral have all the numbers, it doesn't matter how you integrate, dr first or d theta first. So let me write it down. Only if limits are all numbers. So no functions, no functions with x, y, r, and stuff like that. You can rewrite it as 0 to pi integral with respect to theta times 0 to 2 r4 dr, which means doesn't matter which order you choose to integrate. Some students like it, so that's why I'm pointing this out. Let me put it in the beautiful flower. Like so. Only if they're all numbers, order doesn't matter. So you can choose whatever you want to integrate first. From this logic, integral... Oh, no, that was such a good flower. I put effort into this. Maybe it will go back. No, it did not go back. To see it. One more time. Beautiful flower, different color this time. Okay, good. So, with this logic, you see it's very easy to integrate the theta first. Empty integral. Do you know what empty integral is? Empty integral is just the length of the interval. So it's actually just 2 pi. Like this guy is just 2 pi. I don't have to do it so fast, but you can check. Integral of the theta is just theta. Then you plug 2 pi minus 0, gives you 2 pi. That's the definition of integration. If there is no function inside, it's just of the length of the interval. And interval is b minus a. Comes from calculus 1. But you don't have to remember this. I just like it. When I realized it's simple facts, it's just, I felt satisfied that it's much faster. 2 pi right away, 2 pi minus 0. And then you integrate r to the 4, which gives you what? R to the 5. And then you plug 2, r to the 5 over 5. Now let me do it for you. R to the 5 over 5 bar from 0 to 2. And the answer becomes 2 pi times, and in blue I have what? 2 to the 5 over 5. 2 to the 5 over 5. Simplify and you get 64, amazing, pi, no, 64, yeah, over 5 pi, exactly. That is the answer. That is a double integral. So, did you just notice we calculated in 5 seconds, but we spent like half an hour creating it? That's, they kind of bother with different coordinates. We have polar coordinates. We will have spherical coordinates in triple integrals, cylindrical coordinates, and rectangle coordinates in triple integrals. Jumping between them takes more time than actually calculating. But that is the point. Calculating the original integral will take lots of time. So to speed up the calculation, people convert it to polar. Whatever is spinning, whatever have circular motions, is usually calculated not in Cartesian coordinates, in polar or spherical. And then calculations are very easy. So don't be discouraged. Calculations are easy for a reason, because that we used a very good system to calculate it. What do you think about this? Look at this. This homework, I highly encourage you to start it today, because it is going to be challenging. Next. But the good thing, I don't like when students have lots of homework before the exam. So we're supposed to cover 2 chapters this week, and I will not do that. On Thursday, I will not cover new material, and I will not give you homework on Thursday chapter. That chapter doesn't go to the exam. So I feel that's a bad schedule. And just me, right? So only 12.3, which is this, is going to be due Monday, and on Tuesday you have the test. Does that make sense? One more. Evaluate the integral where D is a region bounded by, I think they missed by here. Bounded by. Do you know American notation for bounded by? I really liked it. BDD, bounded by. It's a very, the phrase happens so often, people just decide to shorten it. Bounded by is BDD, but it's only in America though. If you show it somewhere in Europe, they will not recognize it. And then they're given a circle. If you see the circle, if you see x squared, probably it's polar. Probably we should not use Cartesian coordinates. So basically, the explanation of the coordinate system or polar Cartesian system versus polar system, there was a joke that if you end up, if you go to the past in time and you will reinvent the wheel, right? And you will be praised as an amazing scientist. So there was a joke. A person actually did go back in Futurama, if you're curious, in time and reinvented the wheel. So because it was more convenient to like put stuff and then you drag it, right? Like by horse or with a person. Say it's a person drag some kind of goods. But then what is here? Those are wheels. And he made square wheels. So they were squares. And then you can imagine the putush, and then the next one, putush. So it worked. But do you see the flaw here? Like that was squared wheels. That is a very good example, which I just made up 5 seconds ago. Why we should not use Cartesian when polar should be used. This is Cartesian, rise and run. And it will work, but so much harder when you use polar and create a circle out of it. So again, we give you lots of tools, and they were all applied in physics and chemistry and biology. Medical sciences have all of this everywhere because lots of cells are circles. So even the core of the cell is also a circle, and so on. Lots of biological events are happening in cycles. The bacteria is growing, decaying, growing, decaying, growing, decaying, and so on. And that's why polars are very popular. Don't use squares when you should use polar. X squared plus y squared. That's a circle. That's polar. Does it make sense? That's kind of a very interesting example. I just realized. Okay, let's do all the steps again. Step 1, convert the function f. F is x squared. I don't know. What is x squared? What is that? In polar. Go back to the formulas. We only have 3 formulas. One of them should work. R squared cosine theta squared. Where did he get that from? Well, wait. I know where you know where you got it from. Do you know where we got it from? X is r cosine theta, y is r sine squared. We only need for x So x is r cosine theta, and then we squared it because it was x was squared. Thank you. Good job. So at least we know that. Step 2, let's find limits of integration. Usually it is a graph. Let's do a picture. This time they told us it's a circle. And then we don't want the whole circle, or something is going on with the circle. X-axis, y equals x. What is happening here? No idea. So let's sketch that. Let's scratch that. The circle is x squared plus y squared equals 9. What radius that is? Center 0, 0, and radius 3. So we got this. We got this part right away. But this time we don't want the whole circle. But let's at least agree that, I guess let's first finish the graph. X-axis, that's this. This is x-axis. In purple, let's just line. Y equals x. Grab your graphing calculators and graph. Y equals x. That is this line. So we're talking about piece of pie. What is the result of the picture? Circle between x-axis and y equals x. That's a piece of pie. Do you agree? Remember calculus 2, area between graphs? We did it all the time. So it's a segment actually, but we don't need formula for segment here. This is D. You can even name it. This is what they call D. D is not just a circle. It's bounded by a, don't do that, circle, x-axis, and a line, and that's what we got. From here, skip some space. That is my way of doing it, so you don't have to do that. But this is how I do it. I start writing down integral right away. Somehow I feel it's like it's more natural this way, to have thinking process going right away. Double integral f of x, which is x squared dx dy over d equals. Did you practice to do beautiful integrals? So I saw your exams. Some of you have very not beautiful integrals. Some of you have this. So what? It's not going to be like that? Like, don't give me that on the test. This is wrong. I don't want to take points off, but just don't do that. And we're trying to teach you how to be part of the STEM society. Just don't do that. Make sure it's beautiful, either like this or like this, but like not like that. It's not S, okay? It's comes from that idea, but it's stretched. And if you have 4 integrals, this is how they look like. So it will get more in the future. So you should practice having beautiful integrals. Double integral x squared, I will put it in blue, was converted into what? R squared cosine squared. I will write down R squared cosine squared. That's a function. Formula tells me what? R dr d theta. R dr d theta, like a pirate. Very nice. R dr d theta. I got some little pirate pictures on the final exam last time. Now only we have missing limits of integrations. And now they're starting, we need R. So we need R and we need theta. You can start with the obvious one, but it's not always the same. So which one do you want to do first? R or theta? Doesn't matter which you do first. Just whatever you feel is more comfortable. R? Because like R is pretty obvious. I should not say obvious in class so people don't feel bad. Let's do in red. R between what and what? I'm looking at the picture and I see R is 0 for sure, and it's growing, and ends up to be at 3 at any location of this segment. So it's from 0 to 3. Make sense? Find R in order. In this case, it's in the middle, which is not always the case. We're going to have it somewhere in the middle at some point. So the middle one will be from 0 to 3. See, I'm putting it right away. I feel like that's more natural than do integral later. Theta, on the other hand, is not like that. Let me put it in. What color do you like? Red. Let's do Light blue, we already have that. Pink, pink is the same. Oh, yellow. Theta. Theta is between what? I definitely see 0, right? That's what I also, my mindset is like, okay, at least a 0. So I can put 0 here. Yay. Theta is the angle. We're starting with the 0 level. That's where theta is 0 for you to know. And then the rotation starts. And this line, this line in blue tells us the highest level of the angle. If it's higher, then the theta gets bigger. So where do we cut for theta? Do you know? How do you know?
A lot of questions.
Oh, just a second. Oh, how do we know which is one? Pi over 4? Agree, disagree?
Yeah.
How do you know though that it's pi over 4?
Because y equals x, it's just 45 angle.
45 degrees, exactly. Y equals x is a line that divides the first quadrant into halves. The first quadrant in any quadrant is 90 degrees. Half of it is 45 degrees. So it's pi over 4. Amazing. Good job. Yes?
So is it bound by the x-axis because it always starts there?
Yeah.
And it's
Yeah, it was defined like that. Good question. Thank you. That's how they defined polar in the first place. They were choosing, everything that was defined, they had to choose first. They were choosing what to do, and they decided, you know what, let's start with this line. It's called positive x. That's where theta is 0, and then the rotation starts. And in general, in physics and in math, you notice counterclockwise. That's when they like to go. So where should you start then? At this floor on the right. Well, the floor on the right, and then counterclockwise. You go like that. What was your question?
Will there be examples in the lower
Yeah, they will be. Good question. Why the lower bounds are always 0? And just that's what the examples I chose. Good question. No, they can be anything. Like even here, they could choose any other line. Pi over 3. From pi over 3 to pi over 4 now, right? So anything.
My question would be like, how that change the radius?
Oh, the radius. Interesting question. Yes. What if we have a disk with a circle inside, which is empty? That's a donut, right? Then we're going to have from small circle, bigger radius to the bigger one. So if small radius is, say, 2, then R will be from 2 to 3. Oh, very good question. Right? Good job. Very good imagination. Yeah.
What if we have a circle with like L of x? Would it be from like 1 to the radius?
ln of x, good example. Did I made a skeptical face expression? I should keep it to myself. Sorry about that. ln of x usually doesn't go to polar. Rotational stuff go to polar. X squared plus y squared. I mean, I can see that you're trying to find a very hard example, but it's hard in a necessary way. Like, why would you have log in polar? But yeah, if you do, the answer is yes. You still follow the same idea. That was not polite. Sorry about that. Like, roll your eyes to yourself, okay? Like, don't do it openly. From 0 to pi over 4. Pi over 4. Okay, let's finish. Integration will be super simple. While I was blubbing, did anyone actually finish integrating? The answer is following. From 0 to pi over 4, from 0 to 3. R squared and R gives you R cubed. Cosine square stays cosine square. dr d theta. This time, you can still integrate as two integrals if you want. The first integral will be R cubed, and the second integral will be cosine square. But this time, for the practice, and because I skipped a week before the break, I will show you how I do it in my mind. The first integral is the one that's inside. Even if you have 5 integrals, it always starts from inside. So I see R, and I understand that R is a variable. Everything else is a constant. R cubed, so let me copy, 0 pi over 4. The middle integral disappears because I'm integrating. If you finish integrating, there should be no integral. That makes sense. So the middle integral disappears right now. And it becomes R cubed. No, it was R cubed. So R to the 4 bar, and then before the bar. What happens with cosine square? Cosine square theta.
Is that where you wrote R cubed in the equation, but it's R squared?
No, it multiplied. Check it out.
Oh wait, my bad. Never mind.
Thank you. No, good point. Good catch. And you should. I told you, you should catch if I make a mistake. If I see his voice, if I hear his voice, I always concerned. Probably I made a mistake, but not this time. Not this time. What happened with cosine squared? It stays because it's multiplied. It's a constant. So I will put it like in blue, I guess. Cosine squared theta. And then I have a bar in pink. So the integral in pink became that. And the bar is whatever r was from 0 to 3. So and then something is missing before I do equal sign. What is missing? D theta. So you see, in black we have the outside integral. In pink we have inside integral. And when we finish, there will be numbers and theta. And we integrate in terms of theta. So we're converting r into numbers. R used to be a variable, and now it's going to be a number. Because it's a definite integral, and the result of a definite integration is a number. From 0 to pi over 4 is keep waiting. We're calculating. 3 to the 4 is what? 81, thank you. 81 over 4. And I keep in blue cosine square. Okay, you should never assume that 0 gives you 0. Let's plug 0 to the 4 over 4. It is 0. But you should never assume. You can see you make mistakes like that on a test. D, let me put it in pink now. D, in blue, D theta. Theta is from 0 to pi over 4. And now we have outside integral with a constant and then cosine squared theta. Yay, we know how to integrate that. We learned calculus too. How do you integrate that? With the racist cosine. That is a very bad joke. I don't like it. I kind of stopped liking it when I said it third time. What do I mean? What kind of weird stuff I'm talking about? The double angle formula. Let's review that. So people who think that I'm weird now will see what I'm talking about, which doesn't change the fact that I'm weird. Cosine squared theta is 1/2, and there's a sine squared theta, which is also 1/2. And they both 1 plus or minus. Yes, so let's plus or minus. Let me keep that as a secret. And then both of them have cosine double angle. So it's this formula also called reducing the power formula. The difference is plus or minus. And the way I was teaching is cosine likes itself, so it's plus. Sine doesn't like cosine, so it's minus. And then some student on the final exam wrote that, on the midterm I think, that cosine is racist. And I didn't understand it, so I asked the student, what did she mean? And she told me, well, because cosine likes cosine only. I'm like, okay, I guess that's a good point. So, very interesting imagination.
Well, but sine doesn't like cosine as well, so it's kind of racist.
Right. I also I agree with that, right? So, I don't like the whole definition of being racist in terms of trigonometric functions or anyone else. But whatever helps you to remember stuff, just do that, Just use that. 81 over 4. And then I have, let me just put it downstairs. Equals 81 over 4. I will just kick it outside. From 0 to pi over 4, it will be 1/2. Cosine squared gives you 1 plus cosine double angle formula. If there's a double angle, then your substitution is involved, blah, blah, blah. All that kind of stuff. You're supposed to be really good at that. So you better are. 81 over 4 times 2 is 8. And now you're integrating 1 plus cosine 2 theta from 0 to pi over 2. The parentheses around 1 plus cosine is not important. Actually, people do know when the integral starts and ends. Whatever is inside do not require parentheses. Pi over 4. You're right. Thank you. Change that. Pi over 4. Integral of 1 is just the length of the interval, which is pi over 4 minus 0. So the first answer is 81 over 8 times, and this is pi over 4. The first integral gave me pi over 4. Plus cosine integral of cosine gives you sine. Plus or minus?
Plus.
Plus. So I'm going to write down sine 2 theta. But then it's also a u sub inside because of 2 theta. So what is the answer? Divided by 2. Check my shortcuts of u sub. I have a video on that. Like, subscribe. A video on the u sub. Students are praising that shortcut. It's amazing. My shortcuts are definitely getting very popular. It saves so much time on the test and homework. So you don't have to perform the whole u sub. But for the good notes, I'm just reminding you, it is u sub. We just did it fast. We divided by the leading coefficient. Bar from 0 to pi over 4. And finally, we can actually finish that. I will skip that. Pi over 4 plus 1/4. I'll just let you know. 1/4. This whole thing is 1/4. So the answer is 81 over 32. Pi plus 2. It doesn't matter how you write it down. Somehow in my notes it's factored out nicely. It is, that's it, that's the answer.
Before you put the bar, you have to pi over 4 plus something. Does it have to be firstly?
So pi over 4.
Does it have to be just theta there, and then we put the bar?
Oh, you're right. The parentheses messed up. Very good catch. My notation is not good. Bar should be only associated with this piece. Agree. Yeah, very good. And then I factored out 81 over 8. So that's outside. Like so. Parentheses were messed up. Thank you. Very good. Pi over 4. Questions? What do you think? Questions about that? Ask me. Yes?
So for when you plug the pi over 4 into the sine 2 theta,
Uh-huh.
it turns into sine like pi over 2, right? Which should just be 1. So why is it
1.
So then why is it 1/4 instead of 1/2?
Yeah. And my notes, it is probably your, let's see, sine of theta over 2 is 1/2. But isn't it divided by 2 also?
Well, no, so sine
of pi over 2 is 1. So that is 1/2. Probably 1/4 comes from this guy. Probably. Yeah. Probably I just recalculated. So my notes are different. I can see that. Oh, yes, I can see that. I have 81 over 4. And then I, for some reason, put 2 and 2 here. Yeah. Good point. Please fix that. This is 1/2. This whole green parentheses are 1/2. Thank you. Good job, people. Anyone else notice anything weird or have questions or critiques or comments? Before the last example, let me show you some cool stuff. I kind of skipped lots of cool animations. I want to show you this. Some stuff in polar. So we learned that polar coordinates, we learned roses before. All shapes like these, double integrals, we don't do them in Cartesian. Remember, Cartesian functions, we kind of like them to be a function which is 1-to-1, one input, one output. None of this passes vertical or horizontal test. For one input, you have lots of outputs, blah, blah, blah. All the repetitive things are usually done in polar. If they are in 3D, they're usually done in spherical. Can you go? Look at that. How cool is that? R sine 2 theta and R minus sine 2 theta. The roses, they call roses. Purdue University showed this picture of rotation. We already know those 3 vectors. Normal, tangent, B and T and B. But because it's rotational, we also use polar. What is this one? Okay, look at this. A circle into D becomes a spiral. But, do you guys see it? Do you have questions? Please pay attention. A circle into D becomes a spiral or helix. But a disk into D, a disk is a filled-in thing. In 3D becomes a filled-in helix. How cool is that? So that is a ribbon, basically. But it is 2D disk. So that's pretty cool how we're going to go there. That one takes time to load, I remember that. And how did we figure out the area? Double integrals. We're filling everything not with rectangles, but with cubes or cylinders, and depending on the system. Segments also become something interesting. That one did not work, which is fine. Good enough. So, last question is about the ice cream. So look at that. Let's calculate the volume of an ice cream cone. Example. Find the volume of an ice cream cone. I think it's from your homework. So this is, the thing is, if you just find the volume of the cone, for you to know cone is not just the upper half. There's a symmetrical down piece as well. Many people forget about that. But cone actually has two parts, positive and negative. That's why you have to be clear about that. If it's positive cone, you have to point this out. Did they point this out when they call it z equals a square root? Yes. Z equals a square root cannot be negative. It's positive or 0. So just because of the square root, you can already see that they're only using positive height. Z is height. So we definitely know it's not going to be negative. But also, I'm talking about z equals x squared plus y squared, which is not a cone. So let's decide what is going on here, which one is which. But at least we know both of them are positive or 0. Solution. So z equals x squared plus y squared means it have to be positive or 0. But if I'm squaring both sides, I now see the shape of this object. What is the name of the object? Z squared equals x squared plus y squared. It's a sphere. It's basically a circle in 3D. We're adding a third dimension. That's a sphere. Sphere. So I'm gonna draw a beautiful sphere, which is usually like that. It's centered at 0, 0, radius 1. But because z has to be positive, let me point this out with different color. This is y. This is x. Height is z. We only need some part of the sphere. What's the name of that part? Upper part. Upper part of the sphere, which we also called hemisphere. Positive hemisphere. Hemi means half. So what is the other thing then? So we have this function here. We figured out it was a hemisphere. And then we have a second one. The second one is z equals a square root 8 minus x squared minus y squared. It's also positive, so let's remember that. Every time you square both sides, you lose this property of being positive or 0, which means non-negative. Z squared becomes 8 minus x squared minus y squared, which can be written as z squared plus x squared plus y squared equals 8. You might not remember, but that's the function called a cone, a 3D object. That's a cone. And I would draw the whole thing, upper and lower, right? Because that means I'm smart. I'm drawing both. But then I remember that z was positive, so I don't need the negative part. So it's half. Forgot how to write half. Half cone. Yes, thank you. Half cone. And now this is the ice cream. Basically, here is going on. We can always, well, I can show you why it's an ice cream in a second. We find the intersection of those two. How do we know one is bigger than another one and all that kind of stuff? But at least we know that they do intersect like so. Here is, oh, I deleted the professional picture I had. I have it here. Here's the, who is signing so hard? We're almost done. Here's the professional picture. I think I accidentally deleted it. Yes, here it is. See, very interesting, but you can actually move this piece. So the ice cream, like at the very bottom of the cone, if you move it up, it becomes an ice cream cone. How cool is that? And then WTF for you to know, it's want to find. That's not my idea. Want to find. I presented it at a very respectable conference once, and people really liked it. I told them WTF, and all those professors, with old professors, like, oh, and like, want to find. And they're like, oh, like, you see, your brain is nasty, not mine. They loved it. There's a picture of me pointing at WTF at the conference poster. I can send it to you at some point. They loved it. So, but this is not my idea, my friend's idea. Dr. Payam has very good sense of humor. Want to find this intersection. So this is a beautiful picture. This is intersection over here. And you create a double integral. But then you create double integral what? Cartesian? Those too many square roots. Nobody likes to work with square roots. All those Cartesian stuff is annoying. Don't do that. And that's why polar comes in. Whatever is rotational should be polar. Step 1. Convert both functions into polar. Which is very simple. So we have z equals, what was it? A square root, x squared plus y squared, right? Well, what is that then? That is r squared, the square root of r squared, right? Make sense or not? We're converting, we only have several formulas. Let me put it in the red. X squared plus y squared equals r squared. And we have two functions given. Change them first. So that is r. How about the second one? 8 minus blah, blah, blah. Factor out negative sign. So that is just r. The second one was 8 square root, 8 minus, and factor it out, x squared plus y squared. That's how usually people do it. That becomes a square root of, let's find 8 minus r squared. See? So we're converting both functions right away. Does that make sense? So that is a sphere equation of the upper sphere, and that is a cone, upper cone, like so. And now the idea is how to find the intersection. You take the bigger minus the smaller. We did in calculus 1, calculus 2, area between graphs. Literally, it's always the same idea, and that's why it's so pleasant to have this idea. Bigger minus smaller. Volume of that intersection will be double integral, and then we'll have bigger stuff minus smaller stuff. We're doing top minus bottom, but in 3D. So in general, it's bigger minus smaller, that is L, dx dy over d. And we're converting all of this into polar. Double integral. What was bigger? A cone or a sphere? No, whatever is sticking out is bigger. So a cone. So basically, what is... Kind of good question, I guess. Which one is minus which, right? But no, the cone is bigger. So we're gonna do cone first. So we're gonna have this. Okay, I'll just write down cone and write down the equation of the cone right away, which is a square root 8 minus r squared minus, and the smaller one was a sphere. So it's going to be r. Sphere. dr d theta, yes or no? No, there's a mistake. What? R dr d theta. R dr d theta. That's how you do it. Don't forget the r as a pirate. And we only left with one little thing to figure out the limits. What is theta? So that's the step 3. We always do step 3. So it's over d, or you can just finish it right away. Step 3. So I will erase d, and I'll figure out what is my r and theta are doing. R is doing something, and theta is doing something. Theta is easier this time. Theta is rotation around. So if you look down, what is this is the cone of the ice cream. If you look at it from the top, like we had in this cool animation, this one, ice cream from the top is a circle. So that means mapping, that's called mapping, a 3D sphere or ice cream cone onto 2D gives you just a circle and it's filled in, so it's a disk, right? But for now I'm talking about the theta. It will have a whole full rotation from 0 to 2 pi because the shadow have a full rotation from 0 to 2 pi, from 0 to 2 pi. Does it make sense? Because it's not quarter of the cone. We're eating the whole cone, well, at least it's from 0 to 2 pi situation. Since I found theta first, and theta is at the end, I will put it at the end carefully, from 0 to 2 pi. R is measured from something to something. Let's see. We had it, we need to find as an intersection, actually. So it's not that obvious how to find the R. You have to set them equal to each other and solve. Where did I solve? X squared plus y squared. So you have z equals and z equals. Z equals and z equals. The square root x squared plus y squared equals to the square root 8 minus x squared minus y squared. Blah, blah, blah. You change to r. It becomes r equals just r. A square root 8 minus r squared. Square the both sides. You get a quadratic equation. And solve for r. And becomes 2. Yes?
Could you factor out the square root directly before you solve for r, so then it's just like r squared and then 8 minus r squared? It'd be the same thing either way. Like,
Factor out.
well, if you square both sides before.
Ah. Yeah, might work too. Oh, I know what you mean. So it's z squared equals... Oh yeah, good point. Isn't the same thing? Z squared equals z squared. Right. Yeah, good point. Yeah, very good point. Very smart. So it will be 8 minus r squared. So the question was, could we just square first everything and then set them equal to each other? Yeah, the answer is yes. Why not? So that one, so it's going to be 2r squared equals 8. R is 2. Let's check. 2 times 2 times 2, 8. Good point, but we don't need minus. Yeah. That's a very, especially since I mentioned literally last semester, if you forget minus, some panda will cry. So it is plus minus, but we don't need negative radius. But yeah, thank you for reminding. That's a good point. So r is 2 when it's the biggest r, and the smallest is from 0, because the ice cream starts from 0. This is my r, blah, blah, blah. So this is my integral, and you're integrating that. This is how you find the volume of the ice cream cone. You have 2 integrals. There will be u substitution, blah, blah, blah. We don't have to actually do that, but at least let's write down the answer. The answer. So step 4, let me write down. Green is from 0 to 2. 0 to 2. Volume will be 32 pi. If you want to practice integration, do it by yourself. Albert likes to do extra work, so he can check it out. It should be positive, and it's approximately 13.88. What units do you think if it's volume? Well, meters or inches, but I mean it's cubed. Yeah, but thank you. I like meters more, so it's a good idea. Challenging topics, so please start your homework as soon as possible. Do you think you need homework extension due tonight or not? I felt angry yesterday, but actually today I woke up like, So let me know. I could kind of extend it you tonight. I don't mind.
I've gone into it one time with my download, but it was pretty